Thank you. So, dear colleagues, good afternoon. And at this conference, much has been said about the threshold between the IT and so info security and the systems of technological monitoring. So this is kind of being blurred, and so we use similar tools for different tasks. And I would like to kind of dive deeper into this, how the tools that we use, technological monitoring, how it can be done, and I would like to let's say, use the industrial systems of identifying the intrusions or the attacks. And to give you the context, so what is the traditional system of identifying the intrusion? So this is the system of IDS that's working with the traffic that you received, and we have the computer attacks based on the telemetry that we receive from the perimeters. You see these modules, and we have inventory, and identifying the attacks by the signature. And I'm sure that Kaspersky Lab, in our portfolio, we have this product, which is called IT Networks. And lately, so in the market, the security, industrial security, and our portfolio will have these aspects or some processes that affect kind of the distribution of these projects. So it used to be a passive solution, but now we see that this is the single console of the monitoring, and the central piece of it that is linked to the industrial control system, to the ICS. And so you talk about the active elements, cooperation with the logistics controllers, and also you can download some of the config files that describe the current kind of profile of the system. Another important element that influences what's happening at the industrial protocol support, so because the industrial support protocols were maintained and supported from the standpoint of security. But now we see industrial protocols and their analysis at this level solves the questions and issues of the technological control, and simply because the active and passive cooperation with all of these components put all together with the in-depth collection of data helps tackle the problems of identifying anomalies in the work of the system itself. And let's be frank, because the investments into this type of solutions as industrial soft is quite big, and so solving some other tasks that go along with that would justify the investments into security of infrastructure. And some of the examples of how industrial soft can help us, and so energy examples. So Dmitry, thank you very much for building this bridge for my topic, because together with the colleagues of the Rus Hydro and some of the partners, we've been developing the high automated systems, and we're going to use these realities. So this configuration with the ICS is designed, described as the CTFL, and these are the initial data. We upload it in this file, and further on we compare what was going on in the network with how the system was described by the author or the designer. And the first parameter that we analyze, not the anomalies of security, but the anomalies of the local network, the protocol of communication that are part of the standard. From the standpoint of the logic, it works like this. So you upload this file, and so this is just a small file that describes all the rules of cooperation within the system of automatization, and we analyze this file on the basis whether something is right or wrong with this file. You get notification, and then you have this particular file. We monitor the structure, whether it complies with what was initially planned and designed as part of the system. Of course, the communication within this particular standard is being done through several protocols, and the list of technological challenges that we have, infrastructural challenges, you have it on the screen. And but this is an exhaustive list of violations that can arise when we work, when we highly automatized by, let's say, using this specific standard. And another case that I would like to dwell on is the system. Maybe in some other industries, not so much in the energy, but it's true for, and quite often we have the problem that you do not have these tools of verification of its current system, because the engineers somehow influence the configuration, but there's no independent way to verify and agree that this is safe. And let's think about the situation. So this is the real case scenario, that the system, the basic system works well, and all of these segments are activated. But we are humans, and sometimes operators make mistakes, and if something is missing, and if the process is not going, let's say, well, so given the human parameters, so they want to amend the situation, and sometimes they switch off this particular button, and this physically those processes will be, let's say, turned back. But of course, being stressed, he would forget to switch, let's say, this function, and if he forgets, because next time when you have this problem, there will be most probably, and if it's not a catastrophe, but the incident with some other consequences that would influence the business of the company. And what's the role of the solution for that we're talking about? So simply because we can dive deeper into these cases, we can see where the block points are being, let's say, forgotten to switch on, and so we can make the notification so which segment is blocked, and so therefore the crew can make certain attempts to kind of react to this or that situation. And the third case that I would like to talk about is the new way for us, and so this is the application of the engineering systems that we utilize, and we can give different names to it. So, live systems, systems that are of critical importance, but these engineering systems are using the same technology that the classic technology, because we use the same systems of industrial control, with one exception, that they do not have somebody who's looking at those parameters on live mode. So we have the sirens if something goes wrong, but certain number of situations and different parameters that would be great to keep track on, but it's not reasonable given, let's say, the costs. And this industrial segment of automatization can help us work through that. And as a result, to conclude, we do have the system that's been developing in the concept of the monitoring of the informational security, but we understand that this type of solutions can do much more, and therefore the tasks would be the hands-on and the tasks that reflect the daily activities, and we need to adapt those solutions for the specific industries. That allows us implementing different scenarios, and we deal with those issues and problems of cyber protection and building the systems of industrial monitoring. And like we have two tasks, and we save, this is cost efficient, and we invest in a much better way. So those are the scenarios that I mentioned. These are only some of the examples of cases that can be used in this or that way. And we'll be more than happy to get the feedback from you if you have some other scenarios that we kind of play out for you and help you solve those tasks that you face. And to that, I would like to thank you. Thank you very much.